Hello everyone, this is now section 4.3, which is going to be L'Hopital rule. Again, before I start this lecture, so in case if I assign any quiz or any work today, just upload that to the 4.3 quiz tab that I have made on the Blackboard. All right, in the Blackboard, just upload that into the 4.3 quiz in case if I assign something. All right, but anyway, let's do, okay, so I have these two pictures here and I need to find the limit of, so looking at this, okay, this one is going to go down. Okay, so looking at this picture, I have to find the limit of all of this, and looking at this picture, I have to find the limit of all of this, right? So, and we will be using this idea later on when we try to do the actual problem, right? So here, so this is the graph of y is equals to 1 over x, all right? So here, this is approaching towards y-axis. This one is approaching towards x-axis. This one is approaching towards x-axis to the negative side, and y-axis also to the negative side. All right, so now let's find the limit of 1 over x, means the limit of this function when x approaches to 0, and there is a plus on the top, means from the right. When x approaches to 0 from the right, what is 1 over x, or what is y? Then y is going towards positive infinity, right? So infinity. And similarly, from the 0, from the left, if it approaches 0 from the left, then it's going towards negative infinity, right? And for this one, there is no plus minus on the top. So the only time, basically, only time we can find x is equals to just 0 with these kind of pictures is when we have both the value of both of this same. Since we have this one is going towards positive infinity, this one is going towards negative infinity. So in this case, we cannot find the limit of 1 over x when x goes to just 0. So this is undefined. Similarly for this one, now when x goes to infinity, all right, so in this graph, when x goes to infinity or positive infinity, right, positive, so positive infinity, means this, it's going towards this, then x is, or sorry, y is approaching towards 0, right? Because in this y-axis, y is approaching towards 0. So this is 0. Similarly, when limit of x goes to negative infinity, so this is negative side. Again, when x goes to negative infinity, what about y, or what about 1 over x? It should be, maybe some of you guys are thinking negative 0, but well, it's still a 0, right? Because when it's approaching towards this line, this means, well, the y is 0 here in this line, right? So again, it's going towards 0. Okay, now on this one, okay, it's 1 over x squared graph. So again, this one is approaching y-axis positive, approaching y-axis, and this is going towards positive infinity. Also, this one is going towards positive infinity. This is going towards the negative side of x. This is going towards the positive side of x. Okay, here, so this is x goes to 0. There is a plus on the top, so that means it's approaching from the right. If it's approaching from the right, then it's going towards infinity. If it is approaching from the left, it's going to also to the infinity. So now in this case, limit of x goes to 0 is, since these two has the same value, so this is also infinity, right? And now here, x square, 1 over x square when x goes to infinity. So when x goes to infinity, it's similar to this idea. When x goes to infinity, 1 over x square goes to 0. When this one goes to negative infinity, y also goes towards 0. Okay, so we will be using this idea. Please remember this idea here. We will be using this idea to solve um, the examples later on. Let me introduce one more idea here. Um, okay, so let's say we need to find the limit of something when we have something like this form. So you take the limit of something like of this form. X minus c means c is some number to the power n is also some number. Or we have limit of 1 over x minus c to the power n. Right? Again, c is a number, n is some number. So now here, let's consider first case where we say that n is odd. So when we get the n is, well, the power odd, then we can think the limit of this is, or we can compare the limit of this to the limit of this to x. And for this one, we can compare this to the limit to 1 over x, as long as the n here is odd. If n is even, so let's say the second case, if n is even, then we can consider, or we can compare to the limit of x square for these kind of case, and for this kind of case we can compare this to the limit of 1 over x squared, right? And we found these case yeah, we found these case this limit of 1 over x and 1 over x squared in the previous page, right? Right here. So that's why I said that we need to know this idea. So we'll be using this later on. Okay. So let's see an example. Okay, now let's find the limit of 5 over x minus 2 to the power 4. All right, so if you say this one, this is similar to this condition, right? Well, here we have 1 on the top, but here we have 5, but that doesn't make difference. It doesn't matter whatever we have, whatever number we have on the top. If we have some variable, then that will make difference. But as long as we have a number on the top, just a number on the top, it doesn't matter. So this is similar to the limit of 1 over x minus c to the power n, right? And we said that as long as, well, if this n is even, then we can compare this to, so compare this to the limit of 1 over x squared if n is even. What about the x? Well, here we have x goes to 0, or sorry, here we have x goes to 2. So in this case, if there is a number, some number here, we can change, in this case, we can change that number to x goes to 0. All right. If there's an infinity here, we'll stay with the infinity. But if there is a number here, we take the limit that or which is change this number to 0. So take the limit of this, which we have already done it on the first page, right? So if x goes to 0, then 1 over x squared, the limit of this will be infinity. So this one is infinity. So that's why this is also going to be infinity. All right. Similarly, let's say limit of x goes to -2, and from the left 4 over x minus 1 to the power 3. All right, so again, we need to compare this to limit of 1 over x minus c to the power n, right? And if n is r, then we also compare this to the limit of 1 over x, right? If n is even, then we compare to 1 over x squared. If n is odd, we compare to 1 over just x. And again, this limit here on the bottom will be x goes to, well, this -2 will be replaced by 0. But since this is approaching from the left, so we'll still keep that. All right. So now, if you have the picture in your mind of 1 over x and 1 over x squared, like I showed you here, then you can easily find the limit of all of these. Just if you can remember all of, if you can remember this picture in your mind, which is, I guess, it's not too hard to remember this picture, right? So now here, since we're trying to find the limit of 1 over x when x goes to 0 from the left, then this one is approaching towards -infinity, right? From this picture, right? So this is going towards -infinity. So since this one is going towards -infinity, so this is also -infinity. All right. So, but let's say if we have a limit of x goes to, let's say, just 2 when x plus 2, sorry, let's say x minus 3 to the power 4, then in this case, well, I mean, here we can easily, this kind of thing, we can easily see that, okay, we can say the answer easily, right? When we say this goes to 2, then this is 2 minus 3 to the power 4, which will be -1 to the power 4, which is -1. So if there is, we don't have a fraction, then it will be easy to see. But if you have a fraction like this, then it's difficult to find the limit, right? So that's why we compare to the similar equation, and whatever answer we get from there, that will be the same answer to this as well. All right. So yeah, this is the idea for these kind of problems. Okay. So then why don't you, so this is going to be a quiz problem. Well, you'll get the answer in like a few seconds. All right. I think you can get it without even writing all of these things, the answer. But when you submit your answer, make sure you write a whole work. All right. So which equation you are comparing this to, just like I showed here. Just show that and just say what is the answer of this. So this is a quiz problem, all right? So this is a very short quiz, all right? So the whole point of this quiz is to check whether you're watching videos or not, all right? And even when I grade these quiz, I don't really care if you give me the wrong answer, as long as I see you're trying it. So if I see you are trying it, but still you got wrong answer, I don't care. You'll get full grade for that. So I'm not grading this quiz based on the correct answer or not, whether you submit the correct answer or not. I'm just grading this quiz based on whether you try these problems or not. And also the whole point of this quiz is just to check whether you are watching videos or not. That's it. And that's the reason also I signed really easy quiz or very short quiz, right? So this one, you'll just get it answer within like few seconds, all right? Okay, let's keep moving. So now let's start the actual L'Hopital rule thing, all right? So L'Hopital, or even on some book I see it says L'Hospital rule, all right? So different book has different spelling, but since this book has L'Hopital, so we will say L'Hopital. All right, so the L'Hopital rule, well, there are a few rules we need to know. So the first one, let's say if we have the limit when x goes to some number, let's say c of f of x, and this is 0, and also the limit when x goes to c of g of x goes to 0, then we say that the limit of this both function are f of x over g of x is equals to x goes to c f prime of x over g prime of x. So this means if we get the limit of the numerator 0 and the limit of denominator 0, if 0 divided by 0, if you ended up getting 0 divided by 0, then we will take the derivative of numerator, derivative of denominator, and then after that we'll take the limit. And we'll say both of these are same. So this is called L'Hopital rule. All right, so this rule is actually a very popular rule. So if you keep taking advanced math course, then you will probably see this rule a lot of times, all right? So this is very useful rules, all right, and for the future as well. If now we can also use this idea or this rule when we have f of x is equals to infinity, and also the limit of x goes to c of g of x, so it goes to infinity, or well, here instead of saying infinity, let's say we should consider both plus and minus. Plus and minus. For 0, it doesn't matter if we say plus minus. Well, negative 0, positive 0 means still a 0, right? So that's why we didn't say any negative positive for 0. But for infinity, it matters, right? So if you say positive infinity, then it's going towards right. If it says negative, it's going towards left on the x-axis. So it doesn't matter. So that's why it says plus minus. But anyway, so here again, it's the same thing. We have to take the, well, this one is also same as this thing. So we have to take the derivative of f of x and the derivative of g of x. Divided by derivative of g of x. All right, so this is a rule. So let's do an example so it will make more sense. All right, so here I will be doing written like Okay, yeah, 5 problems, right? So, so that you will know what exactly the L'Hopital rule means, all right? So, or how we use the L'Hopital rule and the actual problem. Okay, so let's do the first example. Let's say number A. Okay, let's take the limit of this. All right. So when we take the limit of this, okay, first thing we're saying that x goes to 1. So if x goes to 1, then this thing will be e to the power x is 1 minus e over x is 1 minus 1. So we'll get e to the power 1 minus, well, even though there is nothing on the power, this one still have 1 on the top, right? So this is 0 on the top, divided by 0. So yeah, if you get 0 divided by 0, like I said here, if f of x is 0, g of x is 0, then this will be 0 over 0, right? And here it will be either positive or negative 0 on the top, or either positive or negative 0 on the bottom. So if you end up getting 0 divided by 0 or infinity, doesn't matter, it's positive or negative, infinity divided by infinity, then in this case we'll be using L'Hopital rule. Okay, so here we got this thing. So this thing that we are saying, this is undefined. This is undefined case. Well, 0 divided by 0 is undefined. It doesn't say anything. So in this case, we will be using L'Hopital rule. Okay, so L'Hopital rule says that x goes to 1. Now, using L'Hopital rule, again, using this, we take the derivative on the top, we take derivative on the bottom, both. So we take the derivative of this thing on the top, which will be the derivative of e to the power x is still e to the power x minus derivative of e is, well, e is a number, right? E is some number, 2 point something 71, something, I don't remember, but still this is a number. So the derivative of a number is 0. So we don't have to write that. So even this negative will go. Divide by, on the bottom, now take the derivative of this. Well, here we are. Okay, so one thing you guys might get confused. We are not using product rule here. All right, it's just that we are taking the derivative of the top and the derivative of the bottom separately. All right, so here now take the derivative of x minus 1. So derivative of x is 1, derivative of 1 is 0. So we don't have to write that. All right, so this is different. L'Hopital rule is different than product rule. So, or sorry, quotient rule. Did I say? Yeah, quotient rule. Quotient rule. Well, you take the derivative of this times that. Yep. So that it's not that. You're taking the derivative of the top and the derivative of the bottom separately. All right, now let's check it if you are still gonna get 0 over 0. Now, when you say x goes to 1, then it will be e to the power 1 divided by 1, which is e. There you go. So now this is our final answer. Okay, we got this case, so that's why we use L'Hopital rule. Now using L'Hopital rule, we got the answer. Okay. Now let's do the second one. Okay, now let's take the limit of this one. Where this time x goes to infinity. Okay, so in this case, this is same as e to the power 2 times infinity, which is also e to the power infinity, right? E to the power infinity over here on the bottom, infinity squared is still infinity, right? So this is also same. E to the power infinity is also infinity. If you see the graph of e to the power x, this is something like this, right? So if x goes to infinity, e to the power x also, this one also goes to the infinity. So that's why also on the top there is infinity, and also on the bottom there is infinity. So again, we got infinity over infinity. So that's why I said here, if we ended up getting in, doesn't matter if you have plus or minus, if you get infinity, divide by infinity. We can use again L'Hopital rule. So now let's take, so again, after this, you don't forget to write this limit, all right? If you miss this limit, you will lose points, all right? Because still we haven't taken the limit of this. So that's why we still need to write the limit. So mathematically, it would be wrong if you don't write the limit. So now here, take the derivative of the top. So first I need to take the derivative of this whole thing. So e to the power 2x will be still e to the power 2x. And then take the limit, sorry, take the derivative of 2x, which will be 2, divided by on the bottom, derivative of x squared is 2 times x to the power 2 minus 1. 2 minus 1 is still 1. All right, now let's take the limit. So now if x goes to infinity, again, on the top, we have e to the power 2 times infinity, which will still be infinity. This 2 will not make any difference. It will still be infinity on the top. And also on the bottom, we have 2 times infinity. Well, still infinity. Ooh, okay, so we got infinity over infinity here. We use L'Hopital rule. Again, we got infinity over infinity. So in this case, again, we are going to continue using L'Hopital rule. So again, after this, let's use L'Hopital rule one more time. So now let's take the derivative of the top, this one, which will be, well, we still have this 2, right, 2. But when you take the derivative of e to the power 2x, we still get 2 to e to the power 2x. And again, when we take the derivative of 2x, we have just 2. So 2 times 2 will be just 4. Right? Divide by 2x. Then we take the derivative of 2x, it will be just 2. All right, now see if we get something from this. Okay, so now we still have this 4, but e to the power 2 times infinity will be still e to the power infinity. And on the bottom, we just have 2, 2. So e to the power infinity is still infinity, infinity over 2. All right, so in this case, infinity over 2, we cannot use L'Hopital rule. The only time you can use L'Hopital rule is if you get 0 divided by 0 case or infinity divided by infinity case. All right, so here, infinity divided by a number, well, we don't know that, but this will still be infinity. Infinity is a really big number. So if you divide really big number by 2, that would not make any difference. So this one will still be infinity. Okay, so now here, x goes to -1, x plus 1 divided by x squared minus 7x minus 8. All right, now let's see what we get here first. Okay, so if x goes to -1 on the top, it will be -1 plus 1 will be 0. On the bottom, we get -1 squared minus 7 times -1 minus 8, right? So this will be 0 divided by, so this is +1. This is negative, +7 minus 8 is again 8 minus 8 is 0 over 0. All right, so again, we get 0 over 0, so we can use L'Hopital rule. Okay, now when we take L'Hopital rule, don't forget to write this limit. Now take the derivative of the top, which will be just 1, right? When you take the derivative of x, it'll just give 1. And when we take the derivative of the bottom, we will get 2x minus derivative of 7x is 7. All right, so here now we get so 1 over, if x goes to -1, then it will be 2 times -1 minus 7 will be -1 over 9. Or 1 over -9 or -1 over 9, it's the same thing. Okay, now this one, let's say when x goes to 0 for x squared over e to the power x minus 1, then, okay, so again, let's see what we get here. So when x goes to 0, on the top we'll get 0 squared. On the bottom we'll get e to the power 0 minus 0 minus 1, which will be, on the top is still 0. On the bottom, e to the power 0 is any number to the power 0 is always 1, right? This 0 is gone, so we still have this minus 1. So again, this is 0 over 0. Okay, now this means I can use L'Hopital rule. So using L'Hopital rule, when x goes to 0, on the top, now we can take the derivative of x squared, which will be 2x. On the bottom, take the derivative of this whole thing on the bottom. So a derivative of e to the power x is still e to the power x, minus derivative of x is 1, derivative of this thing is still 0. So you don't have to write that. Okay, now let's see what we get here. So when x goes to 0 on the top, this is still 0. On the bottom, we have e to the power 0 minus 1, which is, I guess, still 0, because e to the power 0 is again 1. 1 minus 1 is still 0. Okay, so again, we have to use another L'Hopital rule. So again, using L'Hopital rule, don't forget to write this limit here again. And again, take the derivative of 2x, which will be just 2 on the top, and on the bottom, derivative of e to the power x is still e to the power x. Derivative of this is 0. Okay, now this is equals to, now if x goes to 0, then we have 2 over e to the power 0, which is equals to 2 over e to the power 0 is 1, so 2. Okay, let me do one more problem, one last problem, and then we're done. So this is the last problem. Let's say if x goes to, let's say in this case, let's say infinity. Natural log of x for x squared. Okay, so here, when x goes to infinity, then the natural log of x, well, if you see the shape of the natural, or the graph of the natural log, this is something like this, which I think I did in chapter 1. Okay, now when x goes to infinity, the natural log of x is also going to go to, well, this is going towards infinity. All right, so on the top, we still have infinity. And on the bottom, infinity squared is still infinity. Okay, so that means I can use L'Hopital rule. So sometimes, well, don't think like when I ask this problem, you'll always get either infinity over infinity or 0 over 0 in the exam. So check it. You might get answer without using L'Hopital rule. All right, so first check it and then start using L'Hopital rule if you ended up getting 0 over 0 or infinity over infinity. Okay. And then the limit, the derivative of natural log of x is 1 over x. And on the bottom, the derivative of x squared is 2x. All right, but before I take the limit, let's simplify this. So I can move this x to the bottom because this one is 1 over x, right? So if I move this to the bottom, it will be x times 2x, which is also, okay, please don't write 1 over 2x squared after this. We still have this limit. So you still need to write this limit here again. All right, if you just write 1 over 2x squared, that will be wrong, because we still haven't taken the limit. So you still need to consider this limit part, right? So 2x squared. All right, so now when x goes to infinity, what is the limit of 1 over 2x squared? All right, so here we have x squared. So this will be similar to 1 over x squared. This 2 will not make any difference. We still have this x squared. So again, we need to consider x squared. So the shape of x squared graph is like this, right? So when x goes to infinity, then 1 over 2x squared is going to, this graph is going towards, on y-axis, this one is going towards 0. So this is 0. All right, so this first thing I showed here, this thing is really useful. All right. Okay, so that's it for this section. I assigned one quiz, a short quiz, a really, really short quiz, which you can do it within a few seconds. All right, and upload that to 4.3 quiz tab in the Blackboard. All right. Okay, I'll see you on the next video. Thank you.